Now we're looking at number 17 here on this test. A summer camp counselor wants to find a length, x, and feet across a lake as represented in the sketch above. So the lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet, respectively. So segments AC and DE intersect at B, and this is important here, angle AEB and angle CDB have the same measure. What is the value of x? So they want us to take away from this question is, hey, we have similar triangles, and hey, we want you to set up some ratios and proportions. So what I did over here on this next page, I just rewrote the first triangle there, and I just labeled the sides they gave me. Because they said AB was 1,800 feet, which is I did there. Segment AB is 1,800. And they also said segment EB was 1,400. And then I'm going to go back to this question here real quick. I want to harp on this part here. Angle AEB and CDB have the same measure. So where is ADB? So if I was to take my little pen, we're doing measure angle AEB. So that's saying that measurement and that measurement have the same angle. And also, what is it? CDB. That's why the other line's there. It's the same measurement. But what do we also know about this triangle? We also know that measure angle ABE and let's just go DBC, they actually have the same angle. They have the same measurement. Because these right here, it's something called a vertical angle. So that actually helps us a lot because that says, hey, these two triangles are similar. They're the same proportion, so you can set up a ratio now. And that's big. So on this next page here, what I'm going to do is actually draw those triangles. However, I'm going to flip the second triangle so that the angles actually match up, quote unquote, so that in the end, I would end up having a triangle with this angle the same and with this angle the same. So how would that look like, actually? It would kind of look like this. Now, it's going to be kind of terrible because I'm bad at drawing, but this is essentially what. And what that allows me to, that frees me what to do is, I know this is 800, and I know this would be 700. Because, again, let me get a different color out. These two are congruent, and these are congruent. And this is great news for me, because now I can set up a ratio. I can now say this side over here on the left, x, over my other ratio, my other side, 1,400. That is equal to, corresponding. The vertical side, so AE, so it'll be 800 over here, and then also 700 over here. I can do this because my triangles are now similar. And now there is a proportion, there's a ratio that I can follow that allows me to do this. And right here, it's just really a matter of solving for x. Now, I won't go through the whole math here just because I'm not going to do all of it. I trust you can multiply and divide. However, you don't have a calculator. So one thing I will harp on and show in this area, I just kind of solve for x here. I'll write over here. 800. Let me rewrite that. Please save yourself the trouble here. Just do this. Take off some zeros here, and we'll take them off on this 8 here as well. This now becomes 1,400 times 8 and divide that by 7. It will help make your life a whole lot easier in the end, trust me. I trust you can do that. But in the end, we'll end up getting a value of x equals 1,600, which fits our picture. Now let's look at number 18 here. I love these type of questions. According to the system of equations above, x plus y equals negative 9, and x plus 2y equals negative 25. What is the value of x? So system of linear equations are a very, very popular very popular question on every single test. They just are. So there are two different methods to solve them, either by substitution or by elimination. Honestly, in this question, you can do either one and it won't be terrible. I've always preferred elimination to avoid doing some algebra, but in this video, I will show you both methods. So in this case, let's start with elimination. The purpose of elimination is to eliminate, quote unquote, a variable. So I want to eliminate either x or eliminate either y. The way I do that is by adding the two equations such that either when I add my x's together or add my y's together, one of them equals 0. So how does it look like here? So if I was to do x plus something, would give me 0. In this case, if I was to do x plus negative x, that would be 0. So let me just do this here. I had to multiply one of these equations by a negative number to get 0. And in this case, I will, you know what? Let me actually multiply my top equation by a negative. It will work out a little bit nicer. So if I multiply my top equation by negative 1, that means I multiply every part by negative 1. So negative 1 times x, negative x. Negative 1 times y would be negative y, and then negative 9 times negative 1 would be 9. And then I'll just rewrite my second equation. So again, purpose of elimination, eliminate a variable. When I add these two equations now, I want one of these two to be 0. And it works out that it does. Negative x plus x would be 0. I'm not going to write it. Negative y plus 2y, that'll be just positive y. And now 9 plus negative 25 would be negative 16. Now in this case, the question is asking what is the value of x. So what I can do now is plug in this y into either one of my two equations. I'll just plug it to the first one because it's a lot more simpler. So x plus y equals negative 9. And then just plug in y. So x minus 16 equals negative 9. X, so add 16. And x will end up being positive 7. So let me show you how to do it now with substitution. So the key with substitution is, obviously it's different from elimination. Elimination, the goal was to eliminate, quote unquote, a variable. So last time we eliminated, I think it was x. In this case, we want to isolate either x or y. What that means is, using our simple equation, which one of the two it is, get x by itself or get y by itself. So x equals blank or y equals blank. So let's look at this question here. X plus y equals negative 9 and x plus 2y equals negative 25. Obviously, the top equation is a lot more simpler. There's no other coefficients within our x and within our y. So I'm going to use our top equation. Substitution, you solve for one of the two variables and then plug that in to the other one. So how does it look like? Let's look at our first equation here. X plus y equals negative 9. So let me write that here. So what I would do here is either solve for x or solve for y. I'm going to go ahead and solve for y because it will save me a step in the end. So to solve for y, I just isolate y. So subtract x from both sides. Negative 9 minus x. Perfect. Let me rewrite that a little bit. But while I'm rewriting that, what I now do is plug this into my second equation. So x plus 2y equals negative 25. But instead of saying y, I'm going to say x plus 2 times negative 9 minus x. And that equals negative 25. Perfect. So like I did. So I took one of my equations, solved for either x or y. I chose y in this case. And then I plugged this into my second equation. So now let's just simplify and solve for x. So x plus distribute this 2, and so we end up getting x minus 18, and then 2 times negative x is negative 2x, and that equals negative 25. All right, let's combine like terms here. We have an x here, and we have a negative 2x right there. Obviously, that would give us negative x. And then we were to do, I'll bring down the 18 here to make this simpler. Again, to solve for x, add 18 both sides. Negative x equals negative 7. Again, isolate x, solve for x, divide both sides by negative 1, and we'll end up getting x is equal to 7. So notice, it didn't matter what process we did, elimination or substitution. In the end, we still got x equals 7. And if we wanted to, we can plug this in into either one of our equations. So if I was to do x, let me put this here, x plus y equals negative 9. And so plug in 7 for x, 7 plus y equals negative 9. We'll end up getting y is negative 16. So elimination, substitution, both give us the same answer. In this case, they just wanted was the value of x, which is 7. But if we wanted to find y, we could find y. So whatever method is easier for you, whatever method makes more sense to you, I would recommend that. And this question, I did elimination when I first did it because my x's canceled out very nicely. But sometimes substitution is better. In this case, substitution is kind of nice. Once it starts getting a lot more fractions, substitution starts to become very messy. That's where I would not recommend it. For example, if this was, I'm just doing this off the top of my head here. I won't fully do this question out. But if I was to have 3x plus 5y equals negative 30, and 2x plus 4y equals negative 25. And I want to solve for x, we use the substitution. Yikes, I would have 3x equals negative 30 minus 5y, divide by 3, divide everything by 3, x equals negative 10 minus 5/3 y. And I have to plug in this x right here into this thing right here. That would be very messy and disgusting because now we get fractions. Elimination works, and so does substitution. Get comfortable with these type of questions because these are very, very common on these type of tests.